Good afternoon and welcome back to the workbench, where today I've just had this faulty power supply dropped off, and the power supply for my lights have also not stopped working, so it's an interesting kind of coincidence. Anyway, so I'm going to have to look at those later, but we'll see what happens. So I'm using this other light, so apologies for the fact the lighting may not be as good as usual. Anyway, so this power supply is out of a computer, obviously. It's a computer power supply. ATX, it's a AcBel Power 510. Model PC7013. It's a passive PFC one. It's got a big PFC coil here, which I quite like. You know, the active PFC power supplies seem to blow up more often, but anyway. And this one has blown up anyway. It doesn't work. Well, I don't know if it's blown up, but it doesn't work anyway. The computer it's in won't power on. And you can see by the fact that it's started pulling it apart that obviously there's something quite wrong with it. But anyway, I just wanted to kind of go over the basic sort of way I test these and see see what happens. So I plug it in and we can test the first thing obviously to do would be to test the 5V standby. So if I go the standard ATX pinout, that's the purple wire. This is a standard one on the Dell. Some older models of Dell, they have a different color scheme. So you have to watch out for that. For this particular one, plug it in, we get absolutely nothing. 0 volts. Completely dead. It's just not outputting anything. So, you know, nothing going into the nothing coming out of this, so that's interesting. So, you know, could be shorted output diode, could be, you know, 5V standby controllers blown up, who knows? Don't know yet. But interesting thing is, okay, well, what we want to check now is it getting any power? You know, is there any power coming in? So if I switch this over to the high voltage range, and we check the main filter capacitors. Now it's got 2 of them because it's a standard one. We got 330 volts across those, so that's what you'd expect. That's completely normal. So it tells us, you know, the fuse is good, the bridge rectifier is good, all that stuff's fine, the coil is fine. So we got our mains voltage coming in, rectified, that's good. So I'll just unplug this, and I'll have a look at something else too. If I probe these capacitors again, I'm probing across both of them, they're in series obviously. 320, the voltage is still there, still quite high, and it's dropping, but it's dropping really slowly. So what that tells me is that there's practically no load on these. They're probably just discharging through the bleeder resistors that are across them. So these will discharge eventually, probably take a couple of minutes, but if the 5V standby circuitry was working at all, I would expect these to, you know, this should discharge much faster. It should be discharged within, you know, 10 seconds or something. So that tells me that the 5V standby circuitry is not doing anything. So if there was a shorted diode on the output, for example, the 5V standby controller would still be trying to power up, and it would be current limiting and shutting down and just power cycling like that, and it would still be drawing current, so you'd see this voltage fall down a lot faster. Since it's not, that leads me to believe that either the 5V standby controller is not getting any power, maybe, you know, open startup resistor possibly, or the controller has just failed completely and just gone open circuit. It doesn't look exploded or anything, just as a first glance, and I can't smell anything burnt, so it may have just silently failed. So what I'll just do is I'll just have a quick look at the pin out for this thing and find out, you know, what pin is power. Is it getting power to that? And, you know, could be just an open resistor or something like that. Who knows? But obviously you want to wait for these mains capacitors to discharge before you start looking at things, before you start handling the board. These ones obviously are not discharging as fast as they normally would, like I said, because there's obviously a fault here, and that is something you do have to watch out for. If you do have a faulty thing, it is more likely that the capacitors will stay charged for longer. Most designs do have bleeder resistors, but they are quite high value, so they won't discharge immediately. I mean, yeah, a couple of minutes, it'll be down to a fairly safe level, but, you know, not straight away. So it is worth looking at that. I mean, what have we got now? Just have another check, actually. I mean, yeah, there's still 200 volts, so you know, it's going down, but it's still quite high. So you don't really want to start poking around in there. But, I mean, by the time I pull out a suitable resistor to discharge them with, they're probably discharged anyway. So yeah, so this chip is a TNY277PN. It doesn't look exploded at all. It doesn't look burnt in any way. Nothing around it looks burnt, to be honest. But yeah, it is fed by a resistor R31. There's a couple other resistors there, so you know, if one of those went open circuit, could be a problem. Yeah, so I'm just going to wait. While I wait for those capacitors to discharge, I'll look up the datasheet for this thing and find out which pin is power, and see if we're actually getting any power directly to the pin of that chip, because if there's no power to it, then it's not going to work. Okay, so the capacitors are finally discharged. I found a 5V resistor here, and my lights decided to start working for some weird reason, so that's useful. Anyway, so I got the data sheet here, I got the pin out. So the pin 4 is the drain, and that's also the supply rail to that chip, so it's all integrated into one pin. It's got an integrated MOSFET inside, and yeah, it's that should be, you know, we should get either 330 volts or so on that pin there. So I'm going to plug it back in again and let's have a quick look and see if we're actually getting that voltage on that pin. And this, of course, is where you want your safety glasses in case your probe slips and something explodes, which is never fun. But anyway, so we got this here on. So a negative connection is there, and if I gingerly poke this pin, we actually get absolutely nothing. So yeah, it's not doing anything. What are the other side of this resistor? Okay, we get a 330 to that resistor. So yeah, that resistor is open circuit, I guess. Okay, so it could be that resistor is open circuit now. Possibly it has failed just by itself, but it also could be that the chip went shorted and blew it out like a fuse. It's probably a fusible resistor going by the colour. Although it doesn't look burnt, but that said, they usually blow out on the underside, but you can't see them, so I'll have to desolder it and have a look. Okay, so this resistor is brown, black, gold, white, so it's obviously, well, it should be 10 ohms. 5%, not sure what the white band is. I suppose it's a temperature thing, or maybe just denoting that it's a fusible resistor, which it probably is. And it's most likely fused, so yeah, well, it could have. Who knows? Yeah, so that should be 10 ohms, or thereabouts. If I just probe that with the actual meter and see what we've got. Making sure, obviously, you've discharged everything first. You don't want to blow your meter up with 300 volts on the ohms range. That's never any good. So if I check that resistor, yeah, it's open circuit. So it should be like 10 ohms or something, and it's nothing. So it's blown for some reason. Typically, given that it's a low value resistor, it's probably, yeah, the chip has probably gone shorted actually, and it's blown that. It's usually the high value startup resistors for trickle charging startup caps for other types of circuits that fail by themselves without any overload. Just, you know, high value, high voltage. They see high voltage and they just fail eventually sometimes. But this one, low value, it shouldn't fail, but it could have, but you know, I don't know. I'm thinking maybe that chip has failed. Again, it doesn't look blown up, but hey, who knows? I shall desolder that resistor, and we'll see if it's blown out on the bottom side. And if it is, then that will explain that. And if not, then it could just be that it's failed by itself, which seems odd, but yeah, who knows, could be. Whoops, forgot to press record on that one. Okay, so yeah, I've desoldered the resistor and just had a quick look, and it's definitely cratered out the side, so as you can see in this close-up photo. So yeah, most likely the chip has gone shorted and it's blown that resistor. Well, like I said, if the resistor failed without any signs of blowing up, then maybe it's just gone open circuit by itself. but yeah, it's obviously blowing. They always usually blow next to the board. I guess that's where the heat builds up, so they burn out on that area first. So yeah, oftentimes they look perfectly fine from the top, but once you pull them out, look underneath, they're blown out. Could be the chip is blown out on the bottom as well, and I just can't see the scorch mark. Sometimes that happens as well. But yeah, or it could have just the resistor could have failed before the chip managed to explode. I don't know. I can't see anything on top or at the sides, but hey. Yeah, so this video, I don't know, it might just be a quick thing of how to diagnose a faulty power supply, but yeah, if I get the go-ahead to repair it, then I'll repair it, and well, I can show that happening. And I mean, yeah, it should really just be a case of replacing that controller and replacing the resistor. So if that's all there is to this, then I'll see you next time. But if not, then I'll come back and we'll have a look at repairing this thing. But yeah, as it stands, it doesn't work, and this is obviously why the chip has probably gone shorted and the resistor is blown out. Alright, so it's the next day. I've got the go-ahead for repairing this thing, so I've ordered the new parts, and I pulled out the original IC, the TNY277PN. So this chip is obviously bad. It's blown the resistor. Everything else in the circuit seems fine, so I'm just going to go ahead and replace that chip and that resistor, and that should hopefully fix it. So I ordered the new parts yesterday, and they've turned up today. Which is good, from RS Components. They do pretty good overnight delivery here. They send everything from Sydney and it comes the next day, so that's nice. It's also worth noting they've changed from using New Zealand couriers to DHL, who hopefully an upgrade, because the New Zealand couriers like to break everything and lose it and stuff. I had a lot of problem with them, so so far no problem with DHL, but anyway, we'll see what happens. So I'll open this up and we'll put the new parts in, and hopefully it'll be fixed. So let's see. Oh, it's a packet inside a packet. Right. Because that makes sense. Right, there you go, TNY277, and some resistors. So, yeah, we can just stick that in. And we need one of these. Now it is worth noting these particular ones are flame-proof resistors, so they will burn out quite a lot less dramatically than a normal resistor would, which is what you want, in these things. It's a safety requirement, basically, in a way. You don't want the thing catching fire and burning up if it does blow up. Oh yes, one other thing I wanted to mention. When I first opened this, there was a dead spider lying on the circuit board around by the bridge rectifier. And that fortunately didn't cause any issues, and it obviously wasn't the cause of the 5V standby controller blowing up. But it is worth noting that insects often do crawl into power supplies and things like this because they run nice and warm, and they seem to be a nice place for them, so they can go in there, and then often they hit the 240 volts or whatever, and they burn up and set things on fire and burn out traces and components and all sorts of things. So yeah, it can be quite annoying if some sort of insect, or sometimes even small lizards, can crawl into things and cause problems. Obviously in this sort of thing you wouldn't get any mice or anything, but it's also a possibility in larger equipment. Yeah, so there we go. Just another thing to watch out for, I guess. Insects that have crawled in and shorted things out. It happens sometimes. But yeah, we got the new parts here, so I'm just going to put these in, and then the thing should work. We got this little plastic shield thing to prevent anything shorting out on the case. I'm just going to take that off and spin it round, get it out of the way, otherwise we can't do anything. And then I'll just stick the new parts in. So this resistor goes over here. It's worth noting that one of the pads, this end pad, is slightly lifted because obviously the heat from the resistor when it was overheating and burning up. So I have to might have to scrape a little bit of solder mask away from the track here and bend the lead over and get a good connection. I don't know if that's going to be a decent joint there. Yeah, and then we've got the IC. Now sometimes you have to straighten these IC pins, and I've got a tool here which I can use to straighten them, but actually going by the previous one I pulled out, the leads don't actually look entirely straight. They are kind of splayed out sidely on the edges of the components. Often you have to straighten them so they're like this, but sometimes they're like that. When you get them, they're like this. So yeah, I'm just looking at this one. It doesn't look like I actually may not need to straighten it, so I'll just try putting it in as it is and see what happens. Hang on. Tweezers might be useful for this. Ah yes, didn't need to bend the leads at all. So there we go. These haven't straightened these at all. I don't know why. Maybe it's to get a better voltage clearance. Something? I don't know. Seems a bit strange, but oh well. That's how they've done it. So there we go. Right. So I'm just going to hold this up because this IC is quite loose in these holes here. So I'm just going to hold this up vertically like this. While I solder one pin, and then I'll push it in and make sure it's all flush. So there we go, and then we can yeah, heat that up. There we go. And now I can put it up the other way and do the rest of the pins. So that all looks good. Now the source pins on this are all connected together, so you don't have to worry about shorting them out. They're all pretty much exactly the same. They're all connected to the same big pad here, so no issue. I'm just going to reflow a couple of components that are around this though, and the transformer pins as well, I think, just in case. Because cracked solder joints on things like the transformer can cause intermittent connections and problems, and sometimes that'll blow up your PSU controller and everything. I mean, these all look fine to me, but I'm just going to do it out of habit. You know, it only takes a few seconds and it's worth it. Just in case, for reliability. What else have we got? Yeah, some wire links here, and some diode. That all looks pretty good. Oh, and that filter cap there. Alright, so solder the resistor back in. And yeah, I think I'll scrape that off, so Just scrape a little bit of this off. Scrape around that lead. Again, we don't want an intermittent connection on that or anything. It's not a good idea, don't want to risk that. And there we go. So that's all looks good. Let me just check. Yep, no shorts, nothing wrong, so that's all good. So let's put that right back around there. Oh yeah, speaking of cold solder joints, there was one on the one I didn't really like the look of on the bridge rectifier here. This pin there, I didn't like the look of that. In fact, I might as well do the whole lot. Again, it's the kind of thing you don't want to get an intermittent connection on these high voltage things, because there's too much chance of issues with the voltage spikes and things going on, and it's more likely to blow things up if there's an intermittent connection, sort of arcing and sparking and doing that kind of thing. So good idea to get rid of anything like that. Unlikely that cause it to blow up, but still. Anyway, so that's all good. So I did miss that capacitor. That's right. I mentioned the capacitor before, and I didn't reflow it. I wanted to reflow those joints. They didn't look too good. And that's where the skill comes of not burning the plastic sheet. Anyway, that's that should be good now. So let's plug it in and see if it works. Right, so let me just make sure everything looks good. Yep. Alright. Let's see. It's all a bit tangled up. So make sure that's unplugged down there. Plug this back in. And if we get the output lead, turn on my multimeter. And if we hang on, stick my glasses back on. the primary filter caps away from your face, just in case. Right, so there we go. 20 volts range. As you'd expect, we want to check 5 volt standby. So if I plug it in, and it's, is that on? Oh, there we go, that's on. There hopefully won't be any fireworks. Alright, no fireworks, that's a good start. Let's see if we got anything here. Yay! 5 volts! 5.09. Looks good. So there we go, 5 volt standby is working again. Okay, so I just had to go out and do some stuff, but I've come back now. I've tied everything up, put the PSU back together obviously, and I'm just going to put it in the computer now and see if it actually goes. So as far as I can tell, everything looks alright, and like we saw, the 5 volt standby rail is now working again, so should be a simple task of just putting it back in the computer and everything should come right back up. So let's just do that and see how it happens. I guess. So not sure where the other screws for this went. It only came with 2 screws, so that's alright though. I'll find another 2 somewhere and put them in. Just a bit kind of wonky only having 2, but for testing this it'll work. Alright, so just got to plug everything back together. So we got 2 hard drives and a CD drive, and there should be, where did I put it? Oh, there we go. SATA power adapter for the CD-ROM drive, I think, yeah. Alright, so I say CD-ROM, it's obviously a DVD drive, but whatever. Anyway, alright, so tuck these cables up out of the way. Go in there like that. What have we got? 12 volt auxiliary power connector. You can go there. Got our main ATX. It's quite good. There's wires are all nice and short and don't have to worry about where they're going. Alright, see, hard drives. Tuck that under there. And it goes to one drive. That goes to the other. And then we got some sort of front panel LED, I think. It goes on here. That's all good. And the video card. Right, that all looks good. So let's plug it in. plug it in. Alright then, so that's all good. Let's switch on. Let's see. Okay, this one doesn't have a thing. But yeah, let's press the power button. To quote someone else, the fan spins and we're done. Alright, so I've dug up an old monitor here and a 5 meter VGA cable because that's about all I had on hand. Yeah, so there we go, and the camera might be a bit washed out at the moment, probably because of all the black it's trying to compensate for. So apologies if that's the case, but let's try it again. Actually, that should be up there. There you go, you got a beep. And seems to be working, so that's good. See if it does anything. Looks good to me. There you go. Windows is booted up. Hopefully the camera has recovered from the color scheme. Oh yeah, no, of course that's not plugged in. Let me plug in my keyboard and mouse here. See if anything happens. Because it's Windows, so oh, there we go. Not too bad. See if it works. Well, I was not going to log in and show you this this computer here, but suffice to say, obviously the power supply works again. Computer's running, so there we go. That was it. Blown 5-volt standby controller and resistor for it. So there we go. TNY277. And its fusible resistor blew out and took the whole supply down. But easy fix, just 2 components. And yeah, that makes the 4th video I've made replacing one of those power integrations integrated power supply chips. Had 1 blown up before and 2 that were overheating and were shutting down, and this is the second one that's blown up that I've made a video of. So yeah, I don't know what it is about those chips. Either they don't like me or they're all just really bad quality. I don't know, but yeah, simple fix though, I guess. I feel easy to get and easy to replace. Yeah, so anyway, that's it for this one, I guess. Not really much to it, but hopefully provided some interesting information about how to troubleshoot power supplies and things to look for. Hopefully it was fun to watch or whatever, and yeah, that's it, I guess. So see you next time.